Alright, this is 5.1. Our objectives for today are the student will be able to find the nth root of numbers, evaluate expressions with rational roots, and solve equations using nth roots. So what we're going to be working today is with radicals. So remember, like the square root of 25 is plus or minus 5, but we're going to be changing this index out front, so you'll see as we go through this. So, first of all, if b to the nth power equals a, then b would equal the nth root of a. So, if I read this, it would be b equals the nth root of a. So in this, n is the index, that's the number that we're taking the root of, the radical, and a is the radicand, the number. So as you look at this, this would be like the cube root of 125. So now we're asking ourselves, what times itself equals 125? So let's say this is x. So we can do this, and we just take the cube root of that, which would be 5. Now if you're doing this on the calculator, it would be the same as, remember we've talked about this, the power is our numerator, and the index is our denominator. So on the calculator, if you simply go 125 to the 1/3 power, it will work it out for you and tell you what the answer is. So our core concept on this, real nth roots of a. So let n be an integer, so we're only working with talking about integers in the index, greater than 1, and let a be a real number. If n is an even integer, we have two cases. We can look at if n is an even integer, so we're taking an even root of the problem. Then if a is less than 0, there's no real roots, because then we're talking about the imaginary numbers. We can't do this if it's a square or a fourth or a sixth. We can't take even indexes of negative numbers. If a equals 0, then there's one real nth root, and that would be simply the nth root of 0 is 0. If it's greater than 0, then we get two real roots. We get plus or minus the nth root of a would be, and again we can do this, plus or minus a to the 1 over n power. Odd integers are different, because when we take negative numbers, that's okay, because negative 5 to the 3rd power would give us negative 125, because we'd have 3 negative signs. So if a is less than 0, there's one real root, and that would be a to the 1 over n. If a equals 0 is one real root, then the nth root of 0 is 0. And if a is greater than 0, then one real root, nth root of a would be a to the 1 over n. Again, so we can do it whether it's negative or positive, doesn't make any difference. We'll only have one answer when that index is odd, because either have to be all odd to get all negative to get a negative, or all positive to get a positive. So if we look at some examples of this, they're going to ask you to find the real nth roots of, so this would be the third root of negative 216. So we know there's one answer, it's negative. Now again, you can do it in the calculator, like this, to the 1/3 power, just, you want to use this symbol. Or in the Desmos, you just put to the power of 1/3. You might have to, on the Desmos, put that in parentheses. But in this case, you should get that n is negative 6. And if we have 4 to the 4th root of 81, and so that would be, again, we can do 81 to the 1/4 power, but that would be 3. So why don't you try these and see if you can work them out. Pause it, come back, and check and see if you got them right. So this would be the 4th root of 16, which is 2. This would be the square root of negative 49, which we can't do. There would be no, we want the real solution, so there wouldn't be one. Again, you would have an imaginary, plus or minus 7i. Oh, and this should be technically, well, let's just do that. So 2, since it's not an equation, we don't need to put the plus or minus. The cube root of negative 125 would be negative 5. And the 5th root of 243, again, you can do this on the calculator, 243 to the 1/5 power, but that would be 3. So hopefully you got those all right. If we go to the next part, rational exponents. So we've talked about this in some of our warm-ups, but we have a fraction in the exponent, like 12 to the 2/3 power. Remember, the denominator is your index, so that'd be the same as the third root of 12 squared. Now you can write it this way, or you can write it, you can do the cube root of 12 first, and then square it. Either way, you'll get the same answer. If you have a negative exponent, remember negative exponents flip it to the opposite where it's located. So in this case, since it's in the numerator, it goes to the denominator. So this becomes 1 over a to the n, which is 1 over the nth root. Again, denominator goes out as the index, numerator stays as the power. Or again, you can write it this way, whichever way. It doesn't make any difference. It's just sometimes it's easier to square it first and then take the index, and sometimes it's easier to take the index first, the root, and then take the power. So as an example, if we look at 16 to the 3/2, so that would be, the denominator is 2. So I don't care here, you don't need to put a 2 because that's what the square root sign means. So here you can see you can do 16 to the 3rd first and then take the square root, but you work with much bigger numbers. Instead, I'm going to do the square root of 16 first, which is 4, and then 4 cubed is 64. If we do 32 to the negative 3 first, 3/5, then it would be the 5th root of 32 to the 3rd, but again, because it's negative, that goes in the denominator. So here again is an example. You can do the 32 to the 3rd power and then take the 5th root, but the 5th root of 32 is 2, so it becomes 1 over 2 to the 3rd, which would be 1/8. So you work with much smaller numbers, usually if you can do the index first. Now on some though, you won't be able to. You know, there is no 5th root of 9. So when we do that, we're just going to go to the Desmos and just type it in as 9 . So we just do 9 to the 1/5 power, and it tells us our answer is 1.551. I want you to round the answers to 3 places, so 1.552. So that would be 1.552. And let's take 12 to the 3/8 power. So again, pretty easy. Just go 12 to the 8b, 3 divided by 8, and we get 2.539. And then lastly, the 4th root. Now, so I can, again on the calculator, I can do it this way. The 4th root is 7 to the 3rd power, or I can do 7 to the 3/4 power. So if we look at this on the Desmos, so we could do, actually I don't know if you can. I would just do it as a fraction, it's much easier. So it was 7 to the 3/4, 7 to the 3 divided by 4 power. And we get 4.034. 4.034. So next, I'd like you to try these. So do these without a calculator, then do these with a calculator, and then come back and check and see if you got it right. So this would be the square root of 4 to the 5th. The square root of 4 is 2. 2 to the 5th is 32. And again, a negative 1/2 power, so I put that on the bottom. So that would be the square root of 9, which would be 1/3. This would be the 4th root of 81 to the 3rd. The 4th root of 81 is 3. 3 to the 3rd is 27. And 1, this would be the 8th root of 1 to the 7th. Well, 1 to the 7th is 1. The 8th root of 1 is 1. So that would be 1. Typing these in, you can just check them on the calculator. 6 to the 2/5. So we get 6 to the 2 divided by 5. and we get 2.048. So 2.408, and then 64 to the negative 2/3 power. So you don't need to change this to a fraction here. You can just go 64 to the negative 2 divided by 3, and it'll just do it to you. It gives us 0.0625, so 0.063. And then again, I'm just going to do this as 16 to the 5/4. Although this one you could have done without a calculator. If you type it in, you're going to get 32, but I could have just done the 4th root of 16 is 2, and 2 to the 5th is 32. So, and then the last one, the 3rd root, so I'm going to do negative 30 to the 2/3 power. So negative 30 to the 2 divided by 3, and we get negative 9.655. Negative 9.665. All right? So fairly easy there. Then the last thing we're going to do is we're going to solve equations involving radicals or nth roots. So the first thing you want to do is write in the form u to the n, which means we're going to get whatever's to the exponent, we're going to get that by itself first and isolate it. And then we're going to, once we get that, where u is an algebraic expression. So it could, we want to get it to something like this. Or more than likely what you'll have, x to the 3rd equals 125. Or we could have like x plus 5 to the 5th equals 62.8. It doesn't make a difference. We just have to get whatever the power is. It just has to be to a singular group. Okay? You can't have something outside of that. So, and then you just take the nth root of both sides. So an example would be on this. We have to get this x to the 5th by itself, so we divide by 4. So we get x to the 5th equals 32, and then we take the 5th root of both sides. Now, again, you can do it this way, or you could have done it 32 to the 1/5 power. Doesn't make any difference, but in either case, x would equal 2. In this case, this 4th power affects everything, so I'm going to do the 4th root of both sides. So on this side, the 4th root and the 4th power cancel, so I get x minus 3 equals, and now we're going to take the 4th root of 21, and because now we're solving an equation, we're going to do plus or minus. So I'm going to go 21 to the 1/4 power. Oops. So we get 2.141. 2.141. And then we're going to add 3 to both sides and get x equals 5.141. So what I'd like you to do now is try these 4 problems. So pause it here, then come back and check and see how you did. So this one, we got to get x to the 3rd by itself, so we divide by 8. X to the 3rd equals 8. Take the 3rd root of both sides. Now again, you can do 8 to the 1/3 power, but x, the 3rd root of 8 is 2. On this one, you should have multiplied both sides by 2 to get rid of the 1/2. So you get x to the 5th equals 1024. And then we're going to take the 5th root of both sides. So that means I'm going to take this to the 1/5 power. And I believe that's 2, but let's check. The 5th root of 1024. 1024 to the 1 divided by 5 power. Oh, it's 4, so not 2. Okay? So that should be 4. And then on this one, again, the 4th power affects the whole thing, so now I do the fourth root of both sides. So I get x plus 5, the fourth root is 16. Now again, it's an even power, so we should be doing plus or minus. And so it'd be x equals negative 5 plus or minus 2. So that would be negative 5 plus 2 would be negative 3. Or negative 5 minus 2 would be negative 7. And then I would always check those to see if they work. Negative 3 plus 5 is 2, and 2 to the fourth power is 16. And negative 7 plus 5 is a negative 2, but negative 2 to the fourth power is also 16. We don't need to worry about that plus or minus with the odd powers. So on this, you take the third root of both sides. So you get x minus 2 equals, and now I'm going to take the third root of negative 14. So negative 14 to the 1/3 power. And we get negative 2.41. So again, it's an odd power, I don't need the plus or minus. Then we add 2, and we get x equals 0.41. So, hopefully you find this fairly easy to do. The assignment is page 241, numbers 5 to 43, the odds, and that will be on the Desmos, or on the big ideas. So, good luck.